Just try to explain them. It's like a revision class. So by now, it's supposed to be something simple. These are 15 questions. Out of these 15, you should be able to do like 10. Well, let's go through it together. Okay. Starting with number 1. We are given that if sine A is equal to 6/10 and sine B is 8/10, find sine A plus B. Now, number 1 is based on trigonometry. We are going to be using the trigonometric function. Now, the first one, we know that sine A plus B. What's sine A plus B? What is sine A plus B? Okay, I'm coming. All right, the first one is sine A plus B. And I'm given that what's sine A plus B? That was sine A plus B plus what? Plus A sine B. Am I right? Yes. So where you have sine A plus B is sine A plus B plus cos A sine B. If it is minus here, this one will be minus in this one. Now, we are given that sine A is 6/10, while sine B is 8/10. So sine A is 6/10, and cos B is 8. Sorry, I wrote the wrong question. This is cos B. We are given sine A and we are given cos B. So we are given sine A and we are given cos B. So from sine A we are going to get, so we are given sine A cos B, but we don't have cos A and sine B. Now there's a way to get that through the normal trigonometric function. You know, when we have a formula that says sine square theta plus cos square theta equals to 1. Sine square theta plus cos square theta equals to 1, right? Okay. Now, if for this one, let's say we are using A, that means sine square A plus cos square A equals to 1. From here, if we make, let's say we make sine square A the subject. In this way, we don't need sine square A, we already have sine A, so that means we are looking for cos A. We already have sine A, we are looking for cos A. And we have cos B, we are looking for sine B. This place we need sine B, and this place we need cos A. So that's the two things we need to find. So now, for us to get cos A from this, by making it the subjects, we take this to the other side, or minus sine square A from both sides. So we have cos square A equals to 1 minus sine square A. The positive becomes negative. Now, if we have cos square A, you know, cos square A is written as cos A squared. So meaning that for us to now get this cos A alone, mean what? We square root both sides. So that the square root will remove the square element and it will affect the other side. So if we square root both sides, we are going to have cos A equal to the square root of what? 1 minus sine square A. So that's the first function we are going to use here. So this will give us cos A, which we need in our calculation. Is there any question from this step? If you don't understand, you want to go back again. Feel free to ask. So that's for A. Now, if you do the same thing for B, so let's say we have sine square B plus cos square B equals to 1, just like the same notion. But now, we don't need cos B because we have it already. What we need is what? Sine B. So sine B will be the subject. The same way. That's sine square B equals to 1 minus what? Cos square B. So just like this, we are going to have sine B equals to the square root of 1 minus cos square B. So this, let's say 1, let's say 2. So this could now be used in the calculation from A to E. These two will be used in the calculation from A to E. Now, taking the question again, we have sine A plus B. So be sine A plus B plus cos A sine B. Now, we can go with number 1 now. Sine A is what? 6 over 10, right? Sine A is 6 over 10. That's 6 over 10 times, like, you know, when you have sine and cos means you multiply. So times, I want to use bracket instead. Now my cos B is given to sine A cos B. Okay, I have these two already, right? I have sine A, I have cos B. So 6 over 10 and what? 8 over 10. That's this first two. We said sine A plus B is sine A plus B plus what? Cos A sine B. So we already have sine A plus B given from the question. But we don't have cos A sine B, which is what we give here as a formula. I think this formula is easy to know. Once you know that, if you are dealing with cos A, that will be the square root of 1 minus sine square what? Sine square A. So A, B. And we have cos B. So I'm going to use the two of them in these workings. Now for this one now, if you multiply this, what do we have? 48 over 100, and 48 over 100 gives us 12 over 25, right? You have a calculator with you. Am I correct? Because 48 over 100 4 goes here 12, 4 goes here 25. You have this. So your fraction will be in the simplest form. So that's for this multiple. Now, for this one now. Now, first of all, we have when you have sine square A, it means you have sine A squared, right? Now, when you have cos square B, it means you have 1 minus answer. 1 minus answer over 25. Now, square root of it, square root of answer, 4 over 5. Do you have it? That's 4 over 5. We do the same thing for the second one. Step by step. That's 8 over 10 from the calculator. We have 4 over 5 in the simplest form. When you square it, that's 16 over 25. Then 1 minus answer, that's 9 over 25. What is square root of 9 over 25? That's 3 over 5. Then you also do the same thing to multiply this side. So you have 12 over 25 plus 12 over 25. And that gives us what? 24 over 25. So this is the answer to question 1. That says sine A plus B. Any question on the first one? So that's the first one. The second one now, we have sine A minus B. Now what's sine A minus B? The sign in between the words we change. Now this one is very simple because it's almost the same thing as this. But the sign in between changing, that means you have 12 over 25 minus 12 over 25. And that gives us what? 0. Because sine A minus B. Sine A minus B. You say it as this minus this. Already we've gotten this one, like sine A cos B to be what? 12 over 25. And we've gotten cos A sine B to be also what? 12 over 25. Difference between the two, that's 0. Now, cos A plus B. The trigonometric function for cos A plus B, that's what? Cos A plus B, right? Minus sin A sin B. Cos A plus B minus sin A sin B. For cos, the sign in between changes. If here is minus, here will be plus. And this one is plus, so it's minus. But for cos, when you have cos A plus B, that's cos A cos B, then sin A sin B. So it's plus, it becomes minus. That's for cos. Now we have everything that we need from the question. We have cos A cos B, also from our calculation. So it doesn't put them. Now, cos A is this one. 1 minus sine square A. And what's that? Where's our 1 minus sine square A? This one. These are cos A, cos A, cos A. That's 4 over 5. In this type of question, the hardest thing is to do the first one. Once you have the first one, you can get the others. Now I said for cos A. Cos A is written as square root of 1 minus sine square A, which is this one, 4 over 5. That's 4 over 5. And our cos B is 8 over 10 from the question. Minus sine A is given 6 over 10. And our sine B is 1 minus cos square B. 1 minus cos square B. 1 minus cos square B. That's 3 over 5. Then we multiply and subtract. So if you do for this, So 4/5 times 8/10. In the simplest form, that gives us 16/25 minus 6/10 times 6/10 is 3/5. So times 3/5 again. That gives us 9/25. If we subtract this will give us 7/25. That's for number 3. Then number 4 is cos A minus B. The only thing that will change here is the sign. Instead of minus here, it's now the plus. So that's cos A plus B plus sin A sin B, which is almost the same thing as this. Meaning this one plus this one now. This plus this. That's 16/25 plus 9/25. That's 25/25, which is 1. Let me give it time to write. Any questions on these ones? 1, 2 first. So then the number 5 out of the E, that tan A plus B. Tan A plus B. You know about tan theta. Tan theta is what? Tan theta is what? It's all these things. Very, very important. Tan theta is what? Tan theta is what? That's sin theta over what? Cos theta, right? But what if I take it upside down? What's cos theta over sin theta? Fourths. Okay. What's 1 minus tan theta? Sec. It's when it's squared, that's when it's sec squared. Abi? And some other things. So those functions. Then also sin squared theta plus cos squared theta equals to 1. Then what else? Then sin sin squared theta is 1 minus. Is it minus? 1 minus cos. Is it minus? It's plus. 1 minus cos 2 theta over what? Over 2. Do you know this one? It's also part of it. Then we also have sin. No, cos now. We also have cos square theta. That's 1 plus instead of minus plus cos 2 theta over 2. This 2 is gotten from sin square theta plus cos square theta equals to 1. This last 2. We got it from sin square theta plus cos square theta, which is 1. For this one, you will say sin square theta plus cos square theta is gotten from that formula. Okay, so back to the question. Tan A plus B. Tan theta. That's sin theta over cos theta. So that was what? Sin A plus B over cos A plus B. So that's what I'm doing. So that is sin A plus B over cos A plus B. Now sin A plus B from the question we'll be doing. That's the first one, which is 24 over 25, right? That's our sin A plus B. I'm using the division sign, up divided by down. So this up, now divided by down. Then cos A plus B, 7 over 25. Division of fraction turns to multiplication. The denominator changes to numerator. That's 24 over 25 times 25 over 7. Right? This comes to, so we have 24 over 7. 3 over 3 over 7. So that's number 1. Although we have more questions like that on trigonometry, but this is the few ones I've been able to go through. And there are some other questions that can say that express tan, maybe like tan 195 degree. You say express it in short form. Yeah, express it in short form. So it might be like an objective question. It will actually be maybe option A, 2 plus square root of maybe 2 all over 5 or something. It might be maybe 2 minus square root of 2 all over 5 or something like that. We know the easy way to do this is by using the calculator. You can also use system calculator too. Look for tan 195. When you get the answer, write it somewhere. For example, tan 195, 0.267. By the time you now check the options, now I'm not sure if this option is correct, but let's just assume. You know, you have 4 options there. So take the first one, just what is square root of 2? You can also do that on the system calculator too. Square root of 2, then plus 2, divided by 5. If that side is not correlating, it's not the one. Go to the next one. I'm sure you will not spend 30 seconds to do that. So that's faster for trigonometry. Then it might also be like you might also say maybe simplify, maybe cos 2 theta, 2 theta all over 2 sin theta, something like this too. But since it's objective, maybe some of the answer is now maybe sin theta. Maybe you now also have maybe cos theta, or maybe now maybe 3 sin theta, or something like that. You also do the same thing. But this one, let your theta be a 9. Something like maybe 45. 45 is easier to. Because 0 might not work, 90 might not work, but minus 45. So let your theta be 45. Or any other ambition. By the time you put it, 2 theta will be 2 times 45 plus 90 minus sin 90 all over 2 sin 45. So by the time you press that, you get your answer somewhere. Check your option. Which one correlates with your answer? That's how you put on. So that's like trigonometric is a little bit simpler if it's objective. It's a little bit simpler. But when it's not theory, you need to recall all those laws. Because we have the compound angle formula, half angle formula, and others. I think there are about 5 different formulas. So that's what But if it's objective, just use your calculator to do this. So any question on number 1 as we proceed to number 2? Any question? So next we are going to take number 2. Number 2 is like is an integration by parts. I think I can rub this one. So this one is not part of the workings. It's just so these are the workings to number 1. So number 2 says you integrate x exponential 2x. In integral by parts, we make it of this formula. Okay. Integral of u dv equals to uv plus integral of v dv, right? Okay, it's minus. Is it minus? Is it minus? Okay, so that's what we use for integral by parts. Integral of u dv minus uv equals to uv minus integral of u dv. Now, how do we get each of these things before we now put them into the equation? Now, when you have this, the first one is your u, while this other one is your dv. The first, no, there's nothing to say. We have the first and the second. The first is your u, the second is your dv. The first is your u, the second is your dv. Now, some questions may not be solved with integral by parts. You know, in integration, we have about, I don't know, there are many steps, many methods, but I think about 5 or more, and 5 or more. So some of them is by substitution, by partial fraction, by parts, by trigonometric function, and other stuff too. This one is by parts, and some cannot be. There are some functions that you can only solve it in one way, and others. Well, when you look at the question, you have to know which one you are working with, and that's the first thing. You have to check which one can I work with. In this case, if I use substitution, can it work? It's no, because now let's assume I use substitution here. If I substitute u to be 2x, you know, when I differentiate 2x, it will give me 2. And there's no how this 2 can cut this x right here. If I differentiate, if I say u is this numerator here, this power here, which is 2x. If I differentiate it, it will give me 2. Now at the end of the day, I'm going to have 1 over 2 du. Now that's this 1 over 2, this 2 now cannot cause this x. So that's why I cannot go with substitution. That's why we have to look for another method to solve it. Okay, now with this one now, our u, as I said, u is the first one, which is x. And the v is the second one, which is e exponential 2x dx. Exponential 2x dx. So u is the first one, the v is the second one with the dx. Now from here, you know, if u is this, that means our derivative u dx is what? 1, right? 1. Now, in this case now, our dv is this. How do we get v from dv? We integrate, right? we integrate. Now normally, inside this place, I'm supposed to integrate, then integrate again. But it's easier when you firstly do it, so that it not make your work easier. Because the first time I checked this, I was trying to integrate 2 times. I integrate like this one 2 times, but do it separately first, before you now continue. Now, the V is the second one. We have to integrate this one. It means for us to get V, we integrate the V, integrate both sides. That's what it means. When you integrate both sides, when you integrate the V, you have V, right? When you integrate the V, you have V. When you integrate the X, you have X. But now, so now you integrate the right hand side. How do we, if we integrate exponential 2x, what do we have? This part 2. No. In differentiation, you said exponential. If you have exponential x and z, it will give you what? Exponential x back. Have you? That's in differentiation. In differentiation, if you have exponential 2x, it will give you what? 2 exponential 2x. That's in differentiation. Meaning that the derivative of 2x here is what? Is 2. That 2 multiplies the equation again. That's for exponential, for differentiation. But as we know, integration is the opposite of differentiation. So if it's now for integration, for exponential x is still exponential x for integration. But exponential 2x, instead of multiplying, we will divide. That's for integration. For division, you are multiplying. But for integration, you what? You divide it. That's how it is over 2. If what you have is over 2. That's for exponential. That's why in one of the formulas that is given in class, it says exponential ax, right? Integral of exponential ax is what? Exponential ax over a plus c. This is the formula for exponential. It means you now divide it by the coefficient of x. That's for the exponential. So if you now apply this here, so that means this will give us exponential 2x over 2, right? We are not writing the plus c because that's how until we get the final answer before we add the constants. So this is, as I recall, u is the first one, the v is the second one with the x. Find the, this is what I have here. Find the derivative of u, then find the integral of the v so that I can get what v. At the end of the day, we have u, the u, and we have v, the v. The 4 things that are needed. U, the u. I can also write this as just the u instead of the u, the x. So u, the u, then v, the v. Those 4 things should be needed for you to now continue with your formula for by parts. Now, if we continue with this, we're going to have integral of our u is x, our dv is this. So integral of this 2x dx is now equals to u is what? X. V is what? Is this exponential 2x over 2. Right? Minus the integral of what we want to write now. V is this one again. That's exponential 2x over 2 into the bracket of our du is what? 1. Assuming it's something else, you know, that's why I put in the brackets. Okay, it should be 1. You can see now that means I'm integrating this one 2 times. That's integral by parts. That means we are doing this one, this second one like this. We are integrating the 2 parts. The first integral is what you use here, but the second integral is what you now use here. So that's why it's better you do it out, you bring it out first before you now put it into the formula. It makes it easier. This is the way I understand now. So from here we will continue this integral of this. So I'm going to have, if it's multiplied as 1 over 2x exponential 2x. Am I correct? Like just multiplying. You know, over 2 means 1 over 2. X exponential 2x. Now minus the integral of this one again. How do you integrate this? Let's 1 over 2 come to the front, right? Then you have integral of 2x. Am I correct? The coefficient here is 1 over 2. The one you have is you have this means 1 over 2 times exponential 2x. So that's what we have here. So 1 over 2, the coefficients in integration, we say bring out the coefficients. Then deal with what? With x, the variable. So if we find the integral of this one, it will give us what back? Exponential 2x over what? Over 2, right? So that would be this one. The u is 1. Yeah. Yeah. The u is dx, I mean, because multiply. Okay. Sorry, I forgot. The u equals to dx because you have 1 here. Because you have to integrate with respect to what? To x, not respect to u. So this one is 1 dx. Like if you cross multiply here, the u over dx equals to 1. If you cross multiply, that means the u equals to 1 dx. The u equals to 1 dx, right? As maybe you have something else here, maybe 2. That's 2 dx. But the 2 will just be here to multiply whatever you have here. The 1 is here to multiply whatever you have here. So that's why when you integrate with respect to x, you can now get this one. So this is important. So from here, this will multiply and we continue. So we have 1 over 2 x exponential 2x minus this one will be what? 1 over 4 exponential 2x, right? Plus c. But that's not the final answer. Now, in the final answer from where I got this one from, we factorize out what is common, which is the highest one here is 1 over 4. But how can we factorize that 1 over 4? We are going to have 1 over 4 into 2x exponential 2x minus, not only 1 over 4, exponential 2x is also common. What is common between these two? Exponential 2x is also here and here. Exponential 2x into 2x minus 1. So this is the answer. Now, why do I put 2 here? Because if you multiply 1 over 4 times 2, this one is not 1 over 4. So if we do 1 over 4 times 2, it gives us 1 over 2 back. And 1 over 4 times 1 gives us 1 over 4. Exponential 2x is common. We bring it out between the two. So this is the final answer from the question that I got it from. You'll see. So this is what we call integral by parts. The first one and the second one. First one is u, while the second one is the v. First one is u, second one is the v. We find our du dx. Then we get our du with respect to what? Dx. That's how we get the u equals to 1 dx. Then we integrate the v so that we can get v with respect to it. That's what we integrate the v so that we can get v. We have this one. Then we now put it into the formula. We now have this equals to this. We multiply this together to have this one. Then we integrate. We firstly multiply 1 times this in the same thing. Assuming this one is 2. 2 you firstly multiply this before you integrate. It might be 3x. 3x you firstly multiply this before you integrate. Then we now have it as this one. Then we bring out what is common. If there's nothing that is common, we leave it as that. Bringing out what is common, then we have this plus c. Integration must be plus a constant. So that's for number 2. Any question on number 2? Okay. Number 3 now. We have the integral of x exponential x squared dx. Now, in this question, when I was doing it, I firstly used integral by parts, but it's not integral by parts for this one. Why is it not integral by parts? If you look at x squared, we can differentiate x squared to give us 2x. So with that, x can cancel x if you multiply. In the former one, you know it was 2x. If you differentiate 2x, we got 2. You cannot cancel x. But in this one, it will become what? 2x. Then x can cancel x. So this one we can use integral by substitution. So even though I write the question to be in between parts, it's not by parts, it's by substitution. Because by the time we start working with it by parts, we get to a point by which we are going to hook and we're thinking of what else to do. So that's that. Okay. So if you use solution for this one, number 4 is by parts, number 3 is by solution. Because in number 4, if you say let u be x squared, that's 2x. X cannot cancel the x in ln, because ln x is different from x. So you cannot say x cancel x. So number 4 is not substitution. So it's by parts. How do you know when you are using by parts? First of all, they be like product rule. You know, in product, in differentiation, we say we have the product rule. One function times what another function when they are beside themselves. So when you have that type of function in integration, there are two things that you can use. Is that you substitute or you use by parts. So in some case you can substitute, mostly by substitution, but in some cases by parts. Like in this one now. So we can say let u to be x squared. If u is x squared, our derivative of u with respect to x will be what? 2x. Now in this case we can make x to be the x to be the subject. So what do? We cross multiply, right? That means the u will be 2x dx. But we are making the x to be the subject. That means we have to start by what? By 2x. That means our dx equals to the u over 2x. Or 1 over 2x du. See the same thing. So this is what we call substitution. Let u, because it's only this one that we can bring out. It will give us 2x so that x can cancel x. Not this one. If we find the derivative of x is 1. What is it cancelling? Not it. The essence of cancelling the x so that we can only have with respect to u alone. We cannot have two different functions and we want to integrate them. Like integral of x and u. It's not possible. So it has to be just one thing. Either u or x. So if the x is now this, if we go back to the equation, that means we have x exponential u. Our u is x squared. That's x exponential u dx. Right? But now our dx is what? Is this. So we put this back into it. We substitute. That means we have integral of x exponential u times the u over what? Over 2x. We put back the value of the x into this. So in this case, x can cancel this x. Because it's like saying you have x exponential u, the u all over 2x. Because what combines them together is multiplication. So when it's multiplication, you can cancel. But if it's plus, you can't. So because multiplication, this can cancel this. So you have integral of, okay, let me write it out first. Exponential u, integral of exponential u du all over 2. Right? Now, this over 2 can come out just like in integration. Over 2, that's 1 over 2. That's the coefficient. It can come out. So we have So we have 1 over 2 integral of exponential u du. That's what we have here. The 1 over 2 comes out, so you have integral of exponential u du. Exponential u is what? Is exponential u. Just like exponential x is exponential x. So that means you have 1 over 2 exponential what? U plus c. But recall now, it must be with respect to x. What's our u? X squared. So you have exponential. So 1 over 2 exponential x squared plus c. So that's the answer to that question. So this one is by substitution, not by parts. Number 2 is by parts. Number 3 is by substitution. I said when you have the products, you are going to check. Can I use it with the first? Can I use it with by parts, or can I use it with substitution? One of them has to work. So I said it's by parts, by substitution, because x there can cancel the x that we have there, so that we can integrate with respect to it. But we can't do that with number 2, and we can't do it with number 4 also. So number 4 is by parts. Okay. Number 4, we have the integral of x squared ln x dx. X squared ln x dx. So I said this one will be by parts, because if you said let u equals to x squared, x squared will now give us 2x, right? That means at the end of the day, divided by 2x. But that x that's at 2x cannot cancel the x here, because it's ln x. But assuming we have something like maybe exponential, and even the exponential cannot cancel. But this one cannot. There's no other can use substitution here. And we cannot say let u equals to x. The derivative of it is 1. So this one is by parts. So once you have products, actually, this type of question is not actually much. I didn't see much of this. So it's not actually, I think I only saw one. This is my test question. I saw it in my question. So it's not actually much. The ones you can really see more are all those ones. Number 12, number 7, number 9. Some other ones, all those ones that you use tan inverse and after and all those laws. But what you get it? So with this one, what do? U is the first one, right? U is x squared. And let's look for u dx first. Our u dx is what? 2x, right? That means our u equals to 2x what? Dx, right? Our du is 2x dx, right? But now we need to look for dx, right? Just like we did in this case. Let's say the u equals to this. So we need dx to be the subject. In this case, dx is already the subject, which is the u. Okay. So u is x squared. No, don't even remember. U is x squared. Just follow this step. Just follow this step. We are going to get into this step. So u is x squared. U is x squared. We find its derivative. That's the u dx is 2x. The u is 2x dx. We stop there for u. Now for v now, the v is the second one. I said the first one will be u. The second one will be what? The v. So the v is this one. The v is lane x dx. The v is this one. Why this one is what? Is u. This is u and this is the v. So this is the v. Now what do we do? We have to get what? V from here. How do we get v? We integrate just like we did there. So we first integrate the v to give you v. So that means we integrate the v and integrate both left and right hand side. Lane x dx. If you integrate the v, it gives us v. If you integrate lane x, what's lane x? 1 over x, right? 1 over x plus constants. But I said we don't need the constant until we get the final answer. So now we've gotten what we need. We have u, we have the u dx. We have v, we have the v dx, which is this one, right? We have u and we have the u. We have v and we have the v. So let's go into the next. Now we now use the formula that says integral of u dv equals to uv minus integral of v dv. So u dv first. So integral of u dv equals to uv minus integral of v dv. Now u dv, u is this first one, the v is what? This second one. That's integral of x squared link x dx equals to, now our u is x squared, our v is this, that's x squared into 1 over x uv. Now our u is x squared, our v is 1 over x minus the integral of our v is 1 over x times, okay, our du is what? 2x dx. 2x dx. That one, because it was 1, it doesn't affect exponentially. But this one is not 1, so it's going to affect what we are doing. Now, left hand side is what we are doing. So this is here. Now, x, one of these x, it means we have x squared over x, right? It means we have 2 of it all over x. So 1, we cancel 1. We are left with what? 1. So that's x. X squared divided by x is what? X. That's what I just explained here. Minus, first of all, we multiply before we find the integral. Minus the integral. Now the same thing here. 1 over x times 2x. That's 2x over x. X and 2x, right? That's 2. So minus integral of 2 here, right? Equals to, now x, we have x minus, what's the integral of 2? In differentiation, when you differentiate 2, it's constant, right? It's 0. But when you integrate 2, it goes 2x. When you integrate a constant, you add x. If it is with respect to x, you add x. With respect to 2, you add 2. So that would be 2x for a constant. If it is 1, it will be x. 2x, 5x, or the sign. So that means you have 2x here plus c, right? And what is x minus 2x? Minus x plus c. This is the answer. Is it? Yeah. This is my answer. parts, like the law. So it's better I teach you the right thing than to teach you the wrong thing. There's a law that my part follows. My part follows this law of arrangements, the lateral. It means, when do we know which one comes first? Is it the first one or the second one? Let's see. Now this I talks about inverse trigonometry. I talked about inverse trigonometry. L talked about logarithm. A talks about algebra. Algebraic equation, like something like x squared, 3x squared, something. Then C talks about trigonometric itself, I think. Then E talks about exponential. For integration by parts, it has a law. So it's not every time you choose the first one. No, it's not like number 3 or number 2. Yeah. So it's not every time you choose the first one. So it has to follow this law. When you have inverse, trigonometry, logarithm, exponential, so we use this Latin law. Now, in number 3, we have x and we have exponential. That means exponential will come last. Exponential is the last one. X there is what? Algebra. X there is algebra. When you have x, or you have x squared, or you have, can also be trinomial, 3x cubed something. That's algebra. So algebra comes before exponential. That's why we said u is the what? Is the algebra, the first one. Like this, the arrangements. But for number 4, we have what? Algebra and what? What's link? Logarithm. We have algebra and logarithm. Between algebra and logarithm comes first before algebra. So that means our u is going to be what? Our u is going to be link x. While our v will be what? X squared dx. We just the arrangements. Because this is the first part of. We are supposed to explain this one first. That's why I also. So this is the first part of integral by parts. This is only for integral by parts. This is the law that you start to follow. The arrangements to know which one comes first. I have other questions. By the time we do this one, I will give out other ones. We are not going to do it, but I will just give it out so that we know which one is first and which one is second. So do this one again. So integral of x squared in x. So we have logarithm and we have algebra. X is algebra. X squared is algebra. So that means logarithm comes before the algebra. So that means our u will be link x. Then our v will be what? X squared dx. That's what it just means. It means the x squared. Now take it with the dx. That's our dv. So this helps you to know the arrangement of integral by parts. So if u is this, u dx will be what? 1 over x, right? Yeah, our ln x is also 1 over x, right? 1 over x, am I correct? Our ln x, du dx is what? 1 over x. My point. Please tell me if I make a mistake, so that I will not be wasting our time. So the u, making the subject, that's 1 over x dx, right? That's 1 over x dx. That's the u. Now we integrate this place so that we have our v. That's integral of the v equals to the integral of x squared dx, right? When we integrate the v, we have v. When we integrate x squared, it gives us what? X cubed over 3. Am I right? Integral means add 1 to the power, then divide by the new power. That's x cubed over 3, right? Plus constant. Yeah. Now we have what we need now. Then to now solve this one, using the formula. So integral of u dv equals to uv minus integral of v du. That's integral of u dv. That's u. That's ln x. Our dv is what? X squared dx. It's still the same thing as this question. This first statement is the same thing as integral of the first question, which is now equals to now. This is what we have business with. Now uv now. U is ln x. That's ln x times v is x cubed over what? Over 3 minus. Now integral of our v is x cubed over 3. Our du is what? 1 over x dx. That's into 1 over x dx. Now, if we continue from here, our ln x cubed over 3. Nothing can cut, so that would be x cubed ln x over 3, right? If this multiplied, that's what we have here. Now, for this one, minus integral, because we multiply one of the x here, we cancel one of the x here, remaining what? 2. That would be integral of x squared over 3, right? Dx. But now over 3, let's bring it out. That's 1 over 3 x squared dx. I said the coefficients will come out. You know, if it's divided by 3, that means 1 over 3 outside. So we have business with this x squared now. After 1x has cancelled 1x. So if we integrate x squared, we are going to have x cubed over 3 also. So this place will now give us, we still have this, so that's x cubed ln x over 3 minus 1 over 3 into x will give us x cubed over 3, right? Plus c. If you multiply, we are going to have x cubed ln x over 3. Now we want to do it like number 2 to get the final, like this one. Minus x cubed over 3 times 3, that's 9, plus c. Now something is common. X cubed over what? Over 9. Over 9. Like this last one. I know it's over 3, but let's use over 9. Right? That would be x cubed over 9 into, this one will be what? 3 ln x minus 1 plus c. Is it not the same thing? So this is the answer. Should I explain again? Yes. Before I explain again, let me give a question that you can quickly go through before. that goes with integral by parts. You can quickly attempt that for those that understand what's I know we okay. You can do those ones while I explain this one again. So this is the question. Integrate, so you can do this two now. This and this. Integral by parts. But mind you, remember this law of arrangement. So integrating again. We have to integrate x squared link x dx. I said we have to follow the arrangement to know which one is our u and which one is our v. Using the Latin law. Inverse trigonometry. What's inverse trigonometry? Like, yeah? Sin or arc sine. So inverse trigonometry like arc sine, arc cos, arc tan, or tan inverse, and that's inverse trigonometry. It's the first one. Then we have the logarithm. We have the algebra. Algebra talks about something like x squared, x, 2x, 3x, those are algebra. Logarithm is like lane or normal logarithm. Then trigonometry talks about the SOHC, cosine, whatever. And also all those tan and it can be sec, it can be cosec. Then exponential talks about e itself. Maybe e raised by x or e raised by 2x, something. Let me write sine. Inverse talk about sine inverse or tan inverse or which ones. So this is the Latin law to know the arrangement of integral by parts. Now when we have this one x squared and in x, this algebra and this logarithm. Logarithm comes before algebra according to the arrangement. Logarithm before algebra. So that's why I say our u will be the logarithm. Why the v will now be the what? The algebra. So if u is ln x, not ln x dx. No, it's the dv that will take the dx. So u is ln x. Why dv is now x squared dx. I expect that will be doing those two. So now, if u is ln x, the u dx is what? Ln x is 1 over x. So if the u dx is 1 over, you make it the u the subject. That's the u equals to 1 over x dx. Like when you cross multiply, just this dx will come here. Assuming what you have here is 2x, that will be 2x dx. It's 1 over x, 1 over x dx. Now for the dv, dv is now x squared dx. To get v from dv means we integrate. So when we integrate dv, we have v. Now to integrate this side, x squared give us x cubed over 3. According to the laws of integration, we add 1 to the power, then you divide it by the new what? By the new power, which is x cubed over 3. Now we've gotten u, we've gotten du. We have v and we have dv. Those are the 4 things we need. U du, v dv. Once you have those 4 things, you now use your formula, which says the integral of u dv equals to uv minus integral of v du. U du, v du, which is this one. Now, our u dv is the question itself. Even though I rearrange it here, it's still the same thing. Because here x squared will come first, right? Before the name. So it's still the same thing. Let me write it this way. X squared x. So just know that your left hand side is still the question. Now for the right hand side is where we are solving. Now u is ln x and v is x cubed over 3 minus integral of v is x cubed over 3 again times what's our du? 1 over x dx with that dx. So that these two, the v and the du, you multiply each other first before you now integrate with respect to x. You multiply this, there's nothing called, you have this one. But when you multiply this, one of these x can cancel one of them here. That's why we have x squared over 2. X squared over 3 rather. But I said now this over 3 is a constant, like the coefficient. We bring that over 3 outside when we want to integrate. That's when you have 1 over 3. You know, x over 3 is empty as 1 over 3 times x. So that 1 over 3 is out. You now have the x. So to deal with, which is this one. Now, integral of x squared, add 1 to the power, divide by the new power. This is what we have here. Now, when you now have this, when you multiply, you have x cubed over 9. Now, trying to check what is common between these two. I didn't make use of over 3. I make use of what? Over 9. Because when I make use of over 3, this one will still be over 3 again. So the essence is so that this one can be what? Linear. Bringing out the common factor out. So that this one can be linear. That's why I didn't use over 3. But in some cases when these two, they are not like almost, what would I say? They are not multiples, right? Something like maybe 2 and 3 now. That one we can leave it as it is. But in this one we can factorize out the bigger one. That's why we use 9 here. In this other one, we use what? 4. Because 2 and 4 they are multiples. So when I now bring out the 9, that's 1 over 9. So that if you multiply, that means what remains is what to give us 9, that's 3. So that's why we say 3 of this. Because when this one multiply this, you have this one back. Because this 3 will cancel 1 of the 3, you have over 3. Then this one will multiply this. Now, it's not only the number now. What other thing is the same? X cube, X cube. You also bring it out. So if X cube over 9 is the same, that's why we have 3 in X. X cube over 9 taken out, minus 1 plus C. Okay? So you can attempt this too. I'm going to proceed to the next one. That's the two questions, the second one, this one, and this one. This exponential x cos x dx, then x cubed sin x dx. Before the exam, we are still going to have another MTA class. continue to number 5. Those 2 questions is doable. It's just like this one too. But by the time you get to, when you're doing this one, by the time you get to this part, you integrate this one just like this. It's doable. Just try it. And after the class, later in the evening, I will do it and send the correction. After the class in the evening, I will do it and send the correction. So those 2. But for now, because of time, let's continue. Now, number 5. Number 5 and 6 is also based on trigonometry. So you can never tell where questions might be from. Now it says in the triangle ABC, now assuming this is my triangle A, B, and C. Now small a is 7. Small b is 6 and small c is 5. We are to find the angle B. We are to find the angle B and then the area of triangle ABC. This type of question is not a right angle triangle. It's a triangle that we use. What law do we use in this type of question? Which law? We have the sine rule and we have the sine rule, right? But you use sine rule. What's the sine rule? Sine A over A equals to, right? Sine B over B equals to sine C over C. This one is the sine rule. Now, what about the cosine rule? Let's start with A. Let's start with A. So, is it A? Okay, yeah. A equals to what? B squared plus C squared minus A. That means this sum of the square of the other one, which is the sum of the square of the other one, B and C, square. Then minus 2 products of it, like minus 2BC. Cos of what? Capital of this one. Cos of what? Capital of B, capital of C. The capital here means the angle itself, while these small letters means the sides. So that's the sine rule and this is the cosine rule. So in this one we have to get B. Yeah, we cannot use the sine rule. For you to use the sine rule, you must have 2 angles. Either you have 2 angles and 1 side, or you have 2 sides and 1 angle. That's when you can use the sine rule. Sine rule, either you have 2 angles, 1 side, or 2 sides, 1 angle. But for cosine rule, you use it when you have these 3 sides, just 3 sides, no angle. Just 3 sides, no angle. You can use your cosine rule. And you can be given 2 sides and 1 angle in a particular way. Then you can also use the cosine rule. Now, to this question, we are looking for B. So we are using what? This second one. We don't have business with the other 2. Now, using this formula, our B, so that means B equals to A squared plus B squared plus C squared. Don't repeat B. So A squared plus C squared minus 2AC cos capital B. You give us this B here. Now, B here is 6, right? So 6 equals to 7 squared plus 5 squared minus 2 into 7 into 5 into cos B. Right? We are just putting the values of each of them. So we have 6 root 2. Is it not a squared, b squared, c squared?
No, it's correct.
It's correct. Just click. Are you sure? It's not looking correct for me. Is it a square equals to b square plus c square? B square equals to it's squared, right? I understand. It's squared. We are not sure. Please be sure. It's squared. A squared, B squared, C squared. Not only A, B, C. Squared. Just like in Pythagoras theorem. You remember, A squared equals to B squared plus C squared. Abi? And so the Pythagoras, it's just like a combination of Pythagoras theorem and SOHCAHTOA. That's the derivative of. You know, there's a way we derive, yes now. There's a way we derive the cosine rule. If you remember, in secondary school, in further maths. Is it further maths? Even in mathematics. There's a way you derive cosine rule using the like this. You now do like this. You now do like this, and you will start now. I've forgotten that derivative. That's how it's done. So the SOHCAHTOA is being applied. It's being applied there, and the Pythagoras theorem. So it's not just A. It's A squared, B squared, C squared. So everything is squared then. So it's A squared equals to B squared plus C squared minus this one now is B and C plus A. Square, 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 square. So this first part is like the Pythagoras theorem. Then this other part is like the SOHCAHTOA. Like a combination of them together. So don't make the mistake of. So 6 squared will give us 36 equals to 49 plus 25 minus 35, 10, like 70, I mean? 70 plus B, right? Okay. So this will give us 36 equals to this and this 70, 74. Right? Is this 74? Yes. Minus 70 plus B. Let's take this one. That was 36 minus 74 equals to minus 20 plus B. This minus what? 38 equals to minus 20 plus B. That's true. Minus 7. Dividing both sides by minus 70, I mean, so that I can get cos B equals to minus 38 over minus 70. Then now, how do we now get B? B is now what? Cos in arc cos, right? Of 38 over 70. I mean, no, minus minus will become plus. So that means I'm looking for arc cos of this one to get B. So what's our value for B? In 2 decimal place. 50 what? 12. Okay. 57.12 degrees. So that's the value of cosine rule. So even though it's find angle A, it's also the same step. If it's angle A, that's A squared is minus 2. That will be A squared B, and you can use the B and C to get your angle A. Like that. Now, assuming the question now says find the other angles, maybe angle B, A, B, C. We've gotten B. To get A, you can easily use sine rule. To get C, you can easily use sine rule. So that's for that one. But now that's the first part. Now the second part of the question says find the area. Hope you know that the area of right angle triangle is different from the area of obtuse angle to triangle. No, acute angle. So the area of right angle triangle is different from the area of this normal triangle. So the area of A, B, sine, C. Okay. So I was able to use this formula. Area is half, half this and side, right? But for this type of triangle, area is half AB sine C. Am I correct? So half AB sine C. If you are not using AB, AB is half AC sine B. Okay, what if I don't want to use that one? Half BC sine what? A. Those are the of this type of the triangle. Have you? No, you can use any of the three. You're supposed to arrive at the same answer. Yes, you arrive at the same answer. Yes, you arrive at the same answer. But now we have A, and we have C, right? You just look at it. But later on, you can go through it, get your angle A, B, C. Use them with these three formulas, you must have the same answer. According to who made the law, he said this, it has to be the same. Now, if you are making use of this now to get the area, which is this second one, based on the angle P that we've gotten. So area will be 1/2. Our A is 7. Our C is 5 sine B. 1/2. This gives us 35/2 times sine 57.12. So your answer is it 14, 13, or 12? Is it 12? What do you get? Just sine 57.12 multiplied by 35 and divided by 2. 40.7. So the one decimal place. What's the units? We don't know whether it's a total meter. Let's write total square. Area is square or okay. Since you don't know, you can say square units. I mean, you don't know the units. If it's centimeter square. If it's feet square. So that's square units. So that's the area of that one. Number 6 is also like number 5 for. So this one, sine rule, very easy. You have two angles already. And out of those two angles, you have one of the sides. So this one is very easy for you to do. I will not do number 6. I will just give the diagram. If it's A, B, and C. For number 6, you have angle A is given as 50 degrees. Angle B is given as 65 degrees. And side, one of the sides of that is given as 5.5 centimeters. So in this one, you don't have small c, small b, and so which means you are looking for what? 3 things. The question says find the angles and the sides of this triangle. So meaning find the angle that remain and what? The other sides that remain, which is this B and C. So if you solve this, you can also get. So you use the sine rule. Which sine rule? Which one are you using for this one? Sine A over what? Because we have A and A. Now B and B now equals to sine B over what? Over B. You can use this one to get your small b. But now, how do you get sine C? How do you get C and C? You use what? Cosine rule, right? Because you don't have this one and you don't have this one. So to get your C and C, you use this cosine rule, this one here. Yes?
There will be 4.
No. There will be 2 on it. So how do you do it?
Use put that in.
This question is to give you a simultaneous equation. You use it to get your C first. By the time you now get your C, you now use sine rule back. You now get your capital C. Why? Because capital C is unknown, small c is also unknown. So the best way for you to do it, by the time you got in your B, or should we do it? No, I'm not doing it. Yes, no. Should we do number 6? Okay, let's do number 6. The next questions we will continue when, as I said, we are still meeting later. Although these questions, the other ones, is something you can attempt. Okay. Wherever we stop, I will send the workings of the others. Wherever we stop. And I think my workings should be a little bit explanatory. Now, if you are using this, that was the sine. A is 50. That's sine 50 all over. Small a is 5.5. So sine 50 all over 5.5 equals to b 65. Sine 65 all over small b. So from your calculator, from your workings, what's the value for b? We are doing it together, so it will be fast. What's b? 6.5. Okay. You can go to your calculator, multiply this one, then divide it by this one. You get your b. You get it faster. So we've gotten b. Now I want to get c and c. So we are going to use these two formulas. So if you use the first one, A is A squared equals to B squared plus C squared minus 2BC plus 8. That will give us 5.5 squared. B is 6.5 squared plus C squared minus 2 Aman. Aman. Is that where I going to do it? Yes. No. I should leave it. But now we have C square. We are still going to have C. I will send the workings later, and we can do it. But I will send the workings. Don't let it take our time. We will do that one later. Number 6. I will solve it. It's actually this way, but it's going to be long. It's this way, but it will be long. So don't let it waste our time. Number. Some of them is yes, it's like that. Where are you going? Sine 50 over 5.5 equals to sine 65 over what? Over b. B is what? 6.5, right? Now to get C, over in the triangle. We have A, we have B, we don't have C. You guys get C, and you cannot tell me. So that's 50 plus 65 plus C equals to 180. Abi? 115 plus C equals to 180. So C is what? 65. So C is 65 degrees. We've gotten C, capital C. Now let's get small c. Sine rule again. Let's use sine B over B equals to sine C over C. That's sine B is 65 over 6.5 sine 65 over C. If you cross multiplying and solve, your C is even C. So that's the answer. C is what? Huh? C is also 6.5. Is that correct? No. It's correct. Okay. It's getting dark. So, I will do number 7. So, by the time we are done with number 7, by tomorrow morning, I will make a video of 8 to 15. Like I will make a recorded video of 8 to 15. So that you can like live stuff, me explaining and stuff. I'll send the link later. You can watch it. But let me do number 7 now to conclude. Is that okay? Don't forget, tomorrow we are still doing statistics. Same time. It starts, we take everything from beginning to the end. From permutation, combination, all the way to iPad, geometry, so Poisson and normal. Now number 7. Number 7. Integral of what? 3x squared. Please call it for me. Plus 18x plus 3 all over 5x minus yes. Now, which method do you use for this one? What method of integration? You say by parts. It's not parting anything. Parts is once you see products, they are like this, and it's not always parts. It can either be parts or substitution. But when you see all over it, now for quotients, you can use two things, either by substitution or by partial fraction. That's the integral of quotients, like integral of division. It's either by substitution or partial fraction. But this one you cannot substitute because the derivative of the denominator is not giving you a numerator, right? So you cannot substitute. So which means this one is partial fraction. But now when you look at this fraction, it's improper. It's improper. Why? Let's check if it's improper. Let your x be 1. What do you get? That's the first thing to start in partial fraction. Check if it's proper or not. If your x is 1, numerator is what? 18 plus 6, that's 24. If your x is 1, denominator is what? 6. Is it proper or not? Improper, right? So in partial fraction, that's what you check. Is it proper or not? When it's improper, you will divide it first. You will divide the function first before you continue. So that's what you check. When you're doing partial fraction, that's the first thing you check. Is it proper or not? So this is improper. Once you use x to be 1 or 0, if it's improper, then that's it. Now, how do we divide? By long division. This is what you want to divide. This is the divisor, right? This is the what? Okay. 3x squared plus 18x plus 3. Then 3x squared plus 5x minus 2. What do we call this one? This is the divisor, right? And this one is the what? Okay. All right. Now to divide, you just take the first and the first, right? That's 3x squared, which is this one, divided by what? 3x squared. So that gives us what? 1, right? Now in long division, you divide, you multiply, and you what? And you subtract. So we have divided now. Now let's multiply. That gives us the same thing back. What's the next thing? What? You subtract, right? Now when you subtract, meaning everything, 3x squared minus 3x squared, 0, right? Now 18x minus 5x, it gives us what? 13x. Then plus 3 minus 2 gives us what? Plus 5. Minus becomes what? Plus. So that's 3 plus 2, that's 5. So now, again, this is the divisor. This is what? Dividend. This is what? Remainder. And this is what? Quotient, right? How do you write your fraction? You write it as quotient plus remainder over what? Divisor. Abi? And now, if you have 4 divided by 3, no, let me say 5 divided by 3. This is the dividend and this is the divisor, right? If you divide this by this, that's 1, right? 1 is the what? Is the quotient. What's the remainder? 2. Over what? The divisor. Is it not the same thing? And 1 over 2 over 3 is 1 plus 2 over 3. So that's what we are using here. So that means we have integral of 1, the quotient first, plus remainder over what? Divisor, plus 13x plus 5, all over 3x squared plus 5x minus 2. Yes. So this one is now this. It is now a proper fraction. What do we now do next? We now use the partial fraction method. Funny enough, some people see this type of question in their test. Now you have to do it within 1 minute at most. Now in partial fraction, we firstly check the denominator, right, to factorize it. Now this denominator can be factorized. Can it? Yes. Let's see. Now we have 3x squared plus 5x minus 2. A and C, right? This A, this C. That's 3 times minus 2, that's minus 6. And this one. Add together to give you plus 5. What's that? 3 and 2. If you say 3 and 2, now how can you multiply 3 and 2 that will give you minus 6? It can't. Multiply something together to give you minus 6. 6 and 1. Now which one we have the sign? Because it's this one that can give you this, and this one gives you this. So that's what you do for this inside. So that means you have 3x squared plus 6x minus 1x or minus x, I just put the 1, minus 2, right? Take what is common, you have 3x is common into x plus what? X plus 2. In factorization, repeat the bracket first, right? So x plus 2. The bracket must be the same. What will be outside? Minus 1, right? So that means you have 3x minus 1 and what? X plus 2, right? Okay. Now, we will continue to this side. So now, we have factorized the denominator. Now, the partial fraction, let's bring it out first. Later on, we'll bring it back in. So that means we have 13x plus 5 all over 3x minus 1 and what? X plus 2, right? We are going to do this into partial fraction, meaning that we want to separate it to become 2. We want to separate it to become 2. Now, if we do for this one now, that means we are going to have A over the first one plus what? B over what? You know that because it's what? Linear and linear. Assuming this one is x squared, it will be what? Bx plus c, right? Because it cannot be factorized. Am I correct? If you have forgotten, you can go back to that one. That's last semester's course. So if it is just 2 linear, A over the first one, B over the second one. If it is 1 linear and a quadratic that cannot be factorized, A over the first one, Bx plus C over the second one. Then if it is repetitive one, A, B, C. So from here, multiply through by the LCM. That means we have 13x plus 5 equals to A will take this, then B will take this, right? A into x plus 2 plus B into 3x minus 1. Right? Now, if you take this first one, x plus 2, that means when x is what? When x plus 2 equals to 0, x equals to what? Minus 2. So wherever you see x, it will be what? Minus 2. So that's 13 into minus 2 plus 5 equals to, if you put minus 2 here, minus 2 plus 2 is what? 0. So this one will be cancelled. So you don't need to repeat this one. So only this one now. That will be b into minus 2 times 3, that's minus 6. Minus 1. I'm only rushing a little because it's late. So this is the last question. Now, this times this gives us minus 26 plus 5 equals to minus this, that's minus 7. Minus 7b. Minus 26 plus 5, minus 21. You will divide both sides by minus 7. B is what? 3, right? Now, to get the second one now, we can take this one, right? But now, you don't have to, because when you take this one, you are going to get 1 over 3. But you don't have to do that. Just take another value for x. I can take 1. I can take 0. I can take minus 1. You still get an answer, and it will be the same. If you take 0, if you take 1, if you take minus 1, you get the same thing. Yes. So let's x equals to, what should we use? 1. So if x is 1, that means you have 13 plus 5 equals to this will become 3a, right? Our b is already what? 3 here. We are going to put it back. That's plus 3 into x is 1, right? 3 minus 1, that's 2. Right? That means 3 times 2, that gives us what? 6. If we continue, this 18. If plus 6 comes to this, that becomes what? Minus 6 equals to 3a. This gives us 12, right? That means a is what? 4. Even if you use x equals to 0 here, you still get a is 4. You can check. It should be the same. It's true. Yeah, it's true. So this a and this b. Now we now put it here. You know that this one is what substitute for this one now. So that means we are looking for the integral of 1 plus these 2 now. Our a is 4. That's 4 over 3x minus 1. Our b is 3. 3 over x plus 2 dx. Now, assuming your a is a fraction, assuming a is 4 over 3, that means this 4 will be up. Then 3 will be down into a bracket of what? Of this one. That's what we just do. Assuming a is 4 over 3, the 4 will be up, then the 3 will be what? Into the bracket of what? Of the denominator. Just in case you see a question like that. And assuming b is minus 3, this sign in between what? Minus. So note those things. Now when you now have this now, we have it in the simpler way we can. We separate them. That means integral of 1 dx plus integral of 4 over 3x minus 1 dx plus integral of 3 over x plus 2 dx. Now, integral of 1, if you integrate 1 is what? I told you earlier, if you integrate 2x, integrate 1, x. That's x plus. Now, we want to integrate this. 4 over 3x minus 1 is the same thing as 4 integral of 1 over 3x minus 1. Am I right? 4 is the coefficient. It's the same thing as this one. You bring out the 4, the x. The same thing to this one also. You bring out the 3, x plus 1, x plus 2. Right? That means you have x plus. Now, if you integrate this 4 into, if you integrate 1 over 3x minus 1, what's the answer? Yeah? Lane what? Lane 3x minus 1 over 3. Over 2 now. You've forgotten? One of the laws that you have in your book, in your own book, it says when you have 1 over, integral of 1 over ax, let's say 1 over ax. When you have integral of 1 over ax, it gives you lane ax over what? Over a plus c. How do they come up with this? It means, what's the derivative of 3x minus 1? The derivative of 3x minus 1 is 3, right? So that 3 will divide lane denominator. You know that lane, integral of 1 over x is lane x. So that's the derivative of this one. We now divide the lane. So this one gives us lane 3x minus 1 all over 3 plus 3 into. Now, what about this one? Integrate 1 over x plus 2. Lane x plus 2. Why is it not over 2? Because the derivative of x plus 2 is what? 1. So if you say lane x plus over 1, you say lane x plus 2. Right? Is this okay? Plus c. Now if we multiply what's needed there, that means we have x plus 4 over 3 lane 3x minus 1 plus 3 lane x plus 2 plus c. That's the answer to that question. So that's integral by partial fraction. 1, 2, 3. So be done within 1 minute at most. And the some people's next question, they saw like 2 or 3 of them. Yes. Yeah, good. So the other ones from number 8 to 15, I will include them and send them across. I will be posting them on TikTok, YouTube. Okay, I will post them in the two. TikTok and YouTube, you see it there. So if you search for this on TikTok or YouTube, you will see the video to, let me say by 12. So you see the video by 12. So we are meeting tomorrow for statistics. So we take it from beginning to wherever we can. So